Alright guys, so we're going to be doing the chapter test review, and I'm most likely going to upload it onto my YouTube channel, and periodically I'm going to be explaining some things and going more into detail than just giving you the answer, because there's no point in that. You can just Google math that, photo math that. So let's look at this first question. Angles 2 and angle 6 are called what? Well, I know angles 2 and 6, they're one on the same side of the transversal to the right. Two, they are non-adjacent, right? 2 and 6 are not next to each other. 2 and 4 are adjacent. 6 and 8 are adjacent, but 2 and 6 are not adjacent. And then the last flag to make sure it's corresponding is that one is in the interior, 6, and one is in the exterior, 2. So that means 2 and 6 are corresponding angles. What are the other corresponding angles that we see here? 2, 6, 1, 5, 3, 7, and 4, 8. Those are the 4 corresponding angles that we have in this problem. Number 2, angles 4 and 5. 4 and 5, I noticed that they're on different sides of the transversal, correct? So I know that they have to be alternate something. They're also both in the interior, so I know that they have to be something in the interior. And what does that narrow down to? Alternate interior angles. The other pair of alternate interior angles are 3 and 6. Okay. Identify all pair of corresponding angles for the lines D and E with transversal A. Okay, so do we care about anything that's going on in transversal B? No, we don't. So 11, 15, 13, 1, all these numbers to the right, we can ignore them because they're not going to matter, because we only care about transversal A transversing D and E. So let's see, what did it ask me? I forgot what it asked me. Corresponding. So the corresponding angles are 8, 5, and 6, and 4. 8, 5, 6, and 4. Perfect. Okay. Identify all pair of alternate interior. So alternate interior for the lines DE with transversal A. So once again, we don't care about B at all, guys. All this goes away. We don't care. What was it again? Alternate interior. So the alternate interior angles are 6 and 9. Now, the reason why 8 and 10 are not alternate interiors is because what transversal is 10 on? Sure, yeah, it's on A, but it's also on C over here. So that means that 8 and 10 are not on the same transversal, right? 10 is on A and C, and 8 is just on A. So that's like the first red flag. 2, it would have to be this entire, if it says, so 6 to 9 is alternate interior, correct? But the 8 would be 10 and 11, because remember, guys, this 10 and 11 make up that entire alternate interior angle that 8 would be congruent to, not just 10 and not just 11. So 6 and 9 are the only pair of alternate interior angles. 6 and 9. Look, they even tried to trick us with this one, but we know that that is not the case, okay? Please don't get confused by that. Okay. Identify all pair of same side interior. So same side interior angles. Same side interior angles for lines D and A with transversal A. Once again, we don't care about B, so we're just going to look here. Same side. 16 and 1 are same side interior. Once again, 6 and 4 are not. You would have to say 6 and 4 plus 7, for example. But we're not doing that. We've never done that. So it's just 16 and 1. Okay, alternate exterior angles. Once again, on transversal line A. Alternate exterior. So we're looking at 9 and 5. Okay. 4 and 6. So angles 4 and 6 are what type of angles? 4 and 6, well, once again, they're on the same side of the transversal, and the transversal is this horizontal line, right? Or sort of horizontal. They're on the same side of the transversal. They are non-adjacent, and one is in the interior and one is in the exterior. So 4 and 6 would be examples of corresponding angles. Okay. With the given information, can it be determined that M and N are parallel? Okay, guys, so remember, in order to know if a pair of lines are parallel, right? If M and N are to be parallel, they need to have one of 4 things. Their corresponding angles must be congruent. Their alternate interior angles must be congruent. Their alternate exterior angles must be congruent. Or their same side interior angles must be supplementary. So let's see if that's the case. Without even looking at this, I just want to first look at what I know. So they give me this, these 2 lines that they're asking if they're parallel, and they give me a transversal going straight down. And I know that 1 and 2, what type of angles are those? Those are same side, because they're on the same side of the transversal, correct? And they're on the interior, both of them. So they have to be same side interior. So in order for me to prove that M and N are going to be parallel, then this angle 1 and 2 have to equal to what, guys? 180. Because if they're same side interior angles, and we want to prove that M and N are parallel, they have to be supplementary or 180. So now we can actually zoom out and see what the question's asking us, or what did they give us? They gave us that measure angle 1 plus measure angle 2 equals 180. So yeah, we can say that the lines are parallel. By alternate interior, no. Corresponding, no. By same side interior. Okay, what is this? In the given figure, which lines or segments are parallel? Okay, so once again, guys, in order to know if something's parallel, we need to gather information based on the angles that lie on the what? On the transversal. So yeah, there are a lot of lines here and line segments, to be honest. But which are the only ones we really care about? Well, remember that, let's first look at the transversal. The transversal line is the most essential, the most important. Now, the transversal line is the line that has what, guys? Your desired angles. So what angle is this on? What angle are both of these guys on? Well, whoops. They're on this line over here, this transversal line, UV. So if I know that UV is the transversal line, well, what 2 lines is that transversal line transversing? Right? So whatever 2 lines that transversal is transversing, we know that because they're what? Alternate interior angles. Not only are they alternate interior angles, but they're congruent alternate interior angles. And what do we know about 2 lines that are being transversed with either corresponding congruent corresponding, congruent alternate interior, congruent alternate exterior, and supplementary same side interior angles? Those 2 lines that are being transversed by any of those 4 properties have to be parallel. So let's take a look. It looks like it's transversing line segments AH and FE. So let's see if we have that down here. AH, FE. AH, FE by alternate interior. Perfect. Okay, what is this? In the given figure, which lines, if any, are parallel? Okay, so once again, which one has to be my transversal? Because I either have that ray R or ray S, right? One of these 2 guys. So is ray R going to be my transversal? Well, yeah, it is a transversal, but is it my desired transversal? Is that the one I really, really care about? No. The transversal I care about is the one that has my desired angles. And what are my desired angles? 115 and 115. Now, in what position are those? Look, if we like zoom out and forget this R, I can't. Oh, right here, right? Let's forget this R. What type of relationship do 115 and 115 have? Well, they lie on the same side of the transversal. They're non-adjacent, and one of them's in the interior, one of them's in the exterior. So what do they have? What relationship are those angles? They're corresponding angles. Not only that, they're congruent corresponding angles, which means that the lines that are being transversed by that ray S has to be parallel. So U and T must be parallel. So let's see if we have that as an option. Right here, U and T, by the corresponding angles theorem. Cool. Okay, guys, this is important. This is going to be on the test. I'm going to make sure it's on the test. Okay? Once again, which one is my transversal? My W is my transversal, right? So my W is my transversal. Let's look at P and Q. If I look at P and I go straight down from P, just P, I'm not looking at K, I'm looking at P. What is the angle that forms when P connects or intersects W? Well, they form a 94. So now let's look at P and Q. What about Q? Q, when Q intersects with W, what angle does that form? 93. Does that tell me anything about the relationship between P and Q? No. All it tells me is that P and Q cannot be parallel. Because in order for P and Q to be parallel, those two angles, the 94 and the 93, must be congruent or equal, right? But those angles are definitely not equal. So I can't see nothing about that. Now, let's look at lines or rays K and M. Well, if we look at K, sure, it says K, the angle between K and P is 17. But do I care about the angle between K and P? No. I care about the angle that is formed when the K intersects with the W, which is what? My transversal. So my K to W, that measure of degree would be what? 111? Something like that? 111. And what would be the angle that is formed when M intersects with W? What's 18 plus 93? Also 111. So therefore, I can say that K and M, when they intersect the transversal, they each have an angle of 111. So what does that tell me about K and M? They have to be parallel. And what is the relationship between K and M? They look like corresponding. They look like congruent corresponding. Perfect. I would suggest when you guys do problems like this, please draw like a little sketch because it is going to help you guys a lot. Okay. Find the value of X for which D and M are parallel. Okay. So they're saying that they want me to find this value of X, whatever X is. And the only clue that they give me is that D and M are parallel. Well, if D and M are parallel, what do you think that tells me about these two angles? What relationship do these two angles have? First, I don't even care about D and M being parallel right now. Let's say that they didn't give us that. What do I know about these two angles? What are they? They're alternate interior angles, right? So now you're probably thinking, Mister, we don't know. Like they could be congruent, they could be different, they could be anything, right? But if we read on, it says, find the value of X for which D and M are parallel. So if D and M are deemed or assumed or whatever to be parallel, then what do I know about these alternate interior angles? They have to be what? Congruent, right? So all you would do is set 2x minus 21 equals 95 because those two angles have to be what? Congruent. Because they have to be congruent because they are alternate interior angles of lines M and D, and M and D are said to be parallel. So they must be congruent. Okay? Okay, find the value of x that makes M and N parallel. Okay, so now M and N, okay. I wish there was a way that I could write on this, but whatever. No, okay. So if we take a look at 122 and M, I'm going to take a picture of this and go on the other page. Okay, I'm going to draw it out really quick. This, I've gotten so used to the one note that it feels awkward doing this. So M and N, M and N, and for the sake of simplicity, let's make our transversal blue. So I know that I have this angle 122 and this angle is 2x minus 16. Now, I know that this guy right here and this guy over here, they're not anything. They're nothing. They're not corresponding. They're not alternate interior. They're not alternate exterior. They're not same side. So you're probably thinking like, man, how am I supposed to figure this out? They don't have anything in common. They're just random angles, and that's true. But remember what I told you, math is very subjective. We can decide how we're going to view things. So can I easily say that this angle here and this angle right here, whatever it is, would be 122? Because they're what? If I already know that it's saying that I want M and N to be parallel, right? Then I know that if I'm assuming that these lines are parallel, then this 122 over here would also be 122 over here, because they would be what? Corresponding angles. And what do I know about corresponding angles that are on the transversal of two lines that are parallel? They have to be congruent. So I can say that this would also be 122, because this and this are congruent. This angle and this angle are congruent. Now do I have a relationship between these guys? Yeah, they're what? They're a linear pair. And what do I know about a linear pair? They're what? Equal to 180. So I could set 122 plus 2x minus 16 equals 180. 122 minus 16. Okay, you guys can figure that out. You guys can figure this out. God darn it. All right, fine, I'll do it. Because now I feel bad. I don't want to be lazy. Okay, 106 plus 2x equals 180. 2x equals 74. And now x is equal to what? 37. 37, perfect. So that's how you go about doing this, guys. That's how you find 188. Now, in a different color, I'm going to do another way that we could have done this, right? What about if I would have recognized that this 122 over here, isn't that just vertical angles, right? Wouldn't these two guys just be vertical angles? So that means that this is 122, so is this going to be 122. And now, what is the relationship between this angle and this angle here? They lie on the same side of the transversal, and they're on the interior. So what could I use to solve these two? I could set them equal to 180. 122, because same side interior angles that lie on the transversal of a transversal that is intersecting two lines that are parallel have to be supplementary. The same side interior have to be supplementary, which means they have to equal to what? 180. And now, isn't this the same exact thing as this. Literally is. So no matter how you do it, you're gonna be able to find another way. I'm sure there's more ways you guys can find it out. You can make this be corresponding angles to here. So now this is also 2x minus 16, and now these two then you could say are a linear pair as well. There's a myriad of ways you guys can do it. I do not care what way you guys do it, as long as you get the correct answer. So shoot, what was it, 37 or something, right? Cool. Okay, now let's keep going. Okay, in the diagram to the right, if 1 and 7 are congruent, so if 1 and 7 are congruent, that's what it's telling me. If 1 and 7 are congruent, what theorem could I use to show that M and N are parallel? Okay, so I'm looking at M and I'm looking at N. If I know that 1 and 7, okay, perfect. Okay, so if I know that 1 and 7 are congruent, what type of angles are 1 and 7? They look like alternate exterior angles to me. And what is the transversal line that 1 and 7 lie on? Line K. So if 1 and 7 are alternate exterior angles, and I also happen to know that they're congruent alternate interior angles, then that means that the transversal line K, whatever two lines, minimum two lines it's intersecting, have to be parallel. Because of what? Because of the congruent alternate exterior angles. So my answer has to be the lines are parallel by alternate exterior angles. Okay. Use the given information to determine which lines, if any, are parallel. Justify each conclusion with a theorem, okay? So if 1 and 8 are congruent, okay, 1 and 8 being congruent, that's the same thing. That's alternate exterior angles. So if my alternate exterior angles are congruent, if 1 and 8 are congruent and they're alternate exterior angles, then that means that my alternate exterior angles are congruent, which means that the transversal that it lies upon, what line are 1 and 8 on that they share in common? My line A. So that means whatever my transversal line A is intersecting, those two lines have to be parallel. And what are they intersecting? U and V. So U and V are parallel because of alternate exterior angles theorem. Perfect. Okay, so guys, this is a lot easier than you think. So I know it's tricky, but let's do it one by one, okay? Find the measure of 1 and 2. Well, I know that measure 1 has to be 127, correct? Because what type of angles are 127 and measure angle 1? They're alternate interior angles. So now the reason, and I'm glad that we got here. Now we're talking about converses, right? Look at these, converse, converse, converse. Remember that what we just finished doing on this chapter 3 test review was everything that had to do with us being given the angles and then determining if these lines are parallel. That was what was 3.2. That's what we've been doing from question 1 through 15. Now what we have is we're given the lines are parallel. You see these two little purple, pink, blue, whatever these two little notations are, they signify that the lines are parallel. And now we want to find the given angle. That's a little bit different than what we've been doing. That sounds like the opposite or the converse of what we've been doing. So for section 3.2, we had that, hey, buddy, here are your angles. Let me know if these two lines are parallel. Now 3.3, what we're doing right now is, hey, buddy, these two lines are parallel. What are your angles? And that we're going to do the alternate interior angle converse, corresponding angles converse, blah, blah, blah. Because the converse, the regular alternate interior theorem is these are your angles, determine if determine if the lines are parallel. Now we're doing the lines are parallel, determine what your angles are. And that is the converse. So we're going to do alternate interior converse. Now also angles whose measure is 127. In order to find out what the measure of angle 1 is, you want to take a look at what? This 127 and apply what property? The alternate interior converse property, angles converse. Now what about measure angle 2? Now there's two ways that I could do it, right? I could do measure of angle 1 and linear pair theorem, right? Because if I have my measure of angle 1, I can find my measure of angle 2 by doing what? The linear pair theorem. Now, the other way I could do it is angles whose measure is 127 and the same side interior converse, which would tell me that what? That 2 is going to be 180 minus 127. Just like if I did the measure angle 1 and linear pair theorem, it would have been 180 minus the measure angle of this 1. So either way, it's going to be one or the other. So that's going to be 53, I think, right? 3 and 5, yeah. And now, okay, so let's look at the measure of angle 1. So remember how we talked about the measure of angle 1 needs to be measure angle 1 and linear pair theorem. That's the only way it could work. So let's see if we have that as an option. Measure angle 1 and vertical angles theorem? No. Measure of angle 1 and same side interior angles? No. So that means our answer is not going to be in the perspective of measure angle 1. So now we have to go through the perspective of measure whose angle is 127. And we already determined that the answer for that has to be measure whose angle is 127 and same side interior. Boom, right? Well, converse. Yeah. Cool? Okay. So let's do this one. Okay. Same thing, guys. Identify all the numbered angles that are congruent to the angle whose measure is given. Okay. So it's saying is angle 1 congruent to the angle that measures 110? Let's see. Yes, because of what? Alternate interior. Guys, it does not matter that this line is not fully drawn. You can draw an imaginary one on your paper. You can do like a dotted line if it's going to help you see it better. So 110 and 1, yeah, they are congruent because of alternate interior angles converse. Cool. What about measure angle 2? No, measure angle 2 would be what? They are what, guys? If I know that these two lines are parallel and this line over here is the transversal, the one that's going like diagonal is transversal, I know that 2 and 10, they're not congruent. They have to be what? Supplementary, because they are same side interior angles. So no, because the two angles are supplementary. That was actually pretty easy. They just gave you one no, which is weird. Is angle 3 equal to measure 110? Yeah, it is. They are what? Corresponding. Measure angle 4? Heck no. They are not, because the two angles are supplementary. And why are they supplementary? Because if 110 and 3 are said to be congruent because of corresponding angles theorem, then 3 and 4 would have to be supplementary because of the linear pair theorem. So that way, so now we can say, yeah, just the same way that 3 and 4 are supplementary, so is 110 and 4, because 3 and 110 are the same thing. So guys, what does that remind you of? The transitive property. If 3 and 4 is supplementary and 110 and 4 are also supplementary, then I could say that, I can't say it right now, but you guys know what I'm talking about. Sorry. So 3 and 4 are supplementary, and 110 and 4 also have to be supplementary. I think you guys know what I'm talking about with the whole transitive property, that they're going to equal, they're going to be the same thing. It's essentially saying the same exact thing. 5. No, 110 and 5 are not congruent. They're what? Supplementary because of the linear pair theorem. So no. Okay. Okay. I guess I'll draw this out. No. Okay. So using measure of angle 5 is 161. So measure of angle 5 is 161. Before I even do anything else, I'm already gonna say, okay, what is measure of angle 5 congruent to, guys? If M and N are both parallel, and I have my measure of angle 5 already, what was it? 161. What else has to be 161? Well, 5 and 7 are congruent because of what theorem? The vertical angles theorem. Now, 5 and 1 are congruent because of the corresponding angles converse theorem, right? The corresponding angles, congruent corresponding angles converse, 5 and 1. And now 5 and 3 also have to be congruent because of the alternate interior angles converse. So I know that 5, 7, 5, 3, and 5, 1 are all also 161. So, okay. 1 is 161. 7 is 161. And 3 is 161. Now, the other angles, 2, 4, 6, 8. In relation to 5, what is the 2 going to be? Well, they're going to be supplementary because they're same side interior, correct? I know that 5 and 8 are also going to be supplementary because of the linear pair theorem. I know that 5 and 6 are also going to be supplementary because of the linear pair theorem. And I know that 5 and 4, although there is not a direct relationship to 5 and 4, I know that 5 and 1 are congruent because of corresponding angles. So if 5 is the same as 1, then I know that 5 and 4, or 1 and 4, same thing, transitive property, they're also going to be supplementary because of the linear pair theorem. So 19, right? Beautiful, perfect. I'm gonna go get water, guys. Give me 1 second. Bought a 24 pack of water for the hurricane. Might as well start using them, right? All right, so look, guys, this one's easy. You guys know this. Find the values of x and y. Well, I know that x is what in relation to 114. If I know that my two lines being transverse are parallel, then I know that 114 and x, that my 114 degrees and x degree have to be what? Congruent, because they're alternate exterior angles. So x has to be 114. Okay, and now I know that what is the relationship between y and 114? They are supplementary. So what is 180 minus 114? That'll give me my y. Or 114 plus y equals 180. And it's the same thing. So 66, right? 66. Okay. Okay, so this one's a tricky one, but this one's kind of fun. So find the measures of the numbered angles in the figure shown to the right, name the theorem. Okay, so let's first look at 1. Whoa. What do I know about the relationship between 1 and 104 or 20. Now, does 20 have anything to do with this? No, because look at the transversal line that's on 20. The transversal line that 20 is on is the diagonal one. Does that have anything to do with 1? Absolutely not. So I don't care about that. So let's look at the 104. I know that 104 and 1 have to be what? Congruent alternate exterior angles. So guys, I think this is the part that most people get confused. So I know that 1 is 104. Right, I think we all know that. Now, the justification. The justification is, how did we get that measure angle 1? Well, we looked at 104. So measure whose angle is 104 and what theorem, or what converse theorem, whatever? The alternate exterior. So measure whose angle is not 20, 104. Corresponding angles converse? No. Alternate exterior angles converse. Now, what about 2? Well, I know that. Let's take a look at, once again, do I look at my 20 at all? Absolutely not, because my 20 and my 2 are not on the same transversal, right? My 20 is on this diagonal transversal. My 2 is on this almost vertical transversal. So now I'm going to look at 104. Now, 104 and 2 have what relationship? They're corresponding angles. So so I know my 2 is going to be 104 for sure. So my 2 is going to be 104. Now, what is the justification? Before I even look at it, let me start thinking of my own. 104. So for measure of angle 2, I already determined it's 104. So I can either say that measure angle whose measure is 104 and corresponding angles. The other one I could say, guys, we just said what's number 1. What is measure angle 1? 104. So can I say measure angle 1 and vertical angles? Because 1 and 2 are vertical angles, and if I know my measure of angle 1, I can say that my justification is measure angle 1 and vertical angles. So I could either say 104, measure whose angle is 104 and corresponding, or I could say measure angle 1 and vertical. So let's see which one it gives me. It'll never give you both, so don't even ask that. It will not give you both. So, okay. 1 in linear pair, nope. 3. No. 3, no. Why 3? 3 is on a different transversal. 20, no. Measure angle 104 and same side. No, they're not on the same side. 104 is in the exterior. Measure angle 3. Once again, I don't care about measure angle 3. I don't know why they keep saying that. Okay, this one, right? It's going to be that one. Measure angle whose 104 and corresponding angles theorem. Now, did they have measure angle 1 and vertical angles? No. So that second option, we could have also had the justification angle measure angle 1 and vertical angles, but we didn't. So we choose the other one, which was 104 and corresponding. Corresponding. Cool. Okay, now measure angle 3. How do I know measure angle 3? Well, is measure of angle 3 now on this vertical transversal? No, it's on the diagonal transversal. So now I'm actually looking at my 20. I'm looking at my 4. Stuff like that. So now, what's my measure of angle 3? Well, it looks like it would be the measure of angle 20, the angle whose measure is 20, and what theorem? Linear pair theorem, right? Because we can clearly see that they're adjacent to each other. Let's look at 3. And what is 180 minus 20? It is 160. So I'm looking for measure of I'm looking for angle whose measure is 20 and linear pair theorem right there. So now let's look at 4. Okay. 4. Okay, 4 is perfect. So I know this can be really, really hard to see, guys. But 3 and 4 are alternate interiors. Ignore everything else other than your line, other than your actual transversal. So I'm going to draw it out. I'm going to draw it out so it's easier to see. So on your paper, I think it'd be smart if you guys were to actually draw it out little by little, right? What does it look like? It looks like this. It looks like this. It looks like that. These two are parallel. It has this. Has that this is. Oh, and it also has this one too. Right? Okay. So I know that I have my 20 over here, 20, my 3, and my 4. Now, do I care at all about this 104, this measure angle 2? No, I don't care about any of that because it's not on my transversal of my 3 or my 4. So I'm not even going to look at it. So you could literally, if you want, just erase this or just not draw it on your scrap sheet. You don't have to draw it exactly. So if I don't care about that transversal, why would I even draw it, guys? Tell me, why would I draw it if I don't care about it? I wouldn't. So now, what do I know about 3 and 4? They're what? Alternate interior angles. And what do I know about alternate interior angles whose transversal, this is the transversal, is transversing 2 parallel lines? I know that they have to be what? Congruent. So I can say measure angle 3, and alternate interior converse theorem. Let's go back. And if 3 was 160, then so is because I'm looking at measure angle 3 and alternate interior. Okay. I think that one's a tough one. Okay. Okay, measure angle 1, that's 78, right? I don't get the trick behind this question. It's just 78. They're corresponding angles. See, I'm not going to disrespect you guys. I'm not going to put that on your test. That's way too easy. Like, come on. That was a joke. All right. So 172 and this 7x minus 3, what relationship do they have? They're what? They're alternate interior angles on the transversal that's transversing 2 parallel lines. So they have to be what? Congruent. So we have to set them equal to each other. So we're just going to have 172 equals 7x minus 3. And I'm too lazy to do the math there. You guys can do the algebra. Also, I don't have a piece of paper next to me, so. Okay. Use theorems. Okay, perfect. So now this is talking about 3.6. Use theorems about perpendicular lines to find the value x in the given figure. Okay, guys. So we talked about this. If we have 2 lines intersecting and they form a 90 degree, what does that tell me about this degree, that degree, and that degree? All 4 degrees that are formed, they're all 90. So if you didn't know that, you at least know that if this is 90, then these guys also have to be 90 because of what? Vertical angles. So now what is 90 minus 56? Or you can say 56 plus x equals 90. And how do we know that? Because of the angle addition postulate. So what is 90 minus 56? 34, right? Sweet. Okay. Refer to the figure to right. Okay, so it's saying measure angle 6 and measure angle 6 plus measure angle 5 equals what? Guys, we know that. 5 and 6. If I know that this measure angle 1 is 90, then I know that this one also has to be 90 because of the property that if 2 lines intersect and they form a 90, all other 4 angles created are 90. But even if I didn't know that, I know that this measure angle 1 and 6 plus 5 is a what? linear pair. So 5 and 6 have to equal 90. Do I care what 5 and 6 are? No. I just care that they equal to what? 90. Okay. The distinct lines ABC are in the same plane. So they want us to tell how A and D relate. Okay. So it looks like they want me to illustrate which of these four has this relationship. Whoops. Has this relationship. A, B is parallel. Okay, so let's... A, B is parallel in A. Okay, so A and B is parallel in all of them except D. So let's cross off D. I'm not picking D. I am not picking D. So I'm just going to take out D there. I'm done with D. I want to look at parallels first because parallels are a little bit easier. So C and D are parallel. So I'm skipping the B is perpendicular, guys. Remember this upside down T means perpendicular. So let's just look at C and D. Okay, in choice A, C and D are not parallel. They're perpendicular. So I'm ignoring that. Okay, this one also C and D are parallel too. Are perpendicular. So my left, but the only answer choice I have is C. But now let's just triple check. Is B perpendicular to C? Darn too, and look, B and C, they're parallel. Oh my gosh. So we didn't even need all three examples, but we just needed the two parallel, but there you go. That's how you go about this, guys. Please do not get scared. Just read your question and go one by one by one. Oh God. Oh, okay. So find the relationship between A and D. So what is the relationship between A and D? If I know that this is 90, then that means this one also has to be 90 because of what? Corresponding angles theorem. Now, if this is 90, what does this one have to be between A and D? It also has to be 90 because of what? Corresponding angles theorem. And remember, I told you guys, if I have two lines that are both A and B are both parallel, C and D are both parallel, that means that everything here matches. So that means this is going to be alternate interior. The A and C is going to be A and C is going to be 90. A and D is going to be 90. Every single angle here is going to be 90. Because when they're both parallel, they all share the same congruent corresponding angles, congruent alternate interior, alternate exterior, and same side interior. They all share the supplementary same side interior. So I know that the line A is perpendicular to B. Let's look at B first. The line A is perpendicular to D because A is parallel to B. B is perpendicular to C. C is parallel to D. Yeah, that one's the one that crosses off everything. All those things make sense. Oh God, another one. Okay. A and B is parallel. So A is not the right answer, so no. Okay, B could be an answer. C is not an answer. And D is not an answer. It's just B, isn't it? Wow, look at that. I didn't even need to go over I didn't even need to look at my other ones. My B is perpendicular to C and C is perpendicular to D because only the A is parallel to B matched with letter B. So that was kind of easy. And now just read it and see what makes what. Remember, guys, a statement, for it to be true, everything has to be true. It cannot just be one part. It has to be everything. Okay? So, find the relationship between A and D. Choose the correct answer below. Find the relationship between A and D. Choose the correct answer below. The line A is perpendicular to D. No. A and D is not perpendicular, so A is not an option. The line A is parallel to D. That's true. Because A is parallel to B, yes. B is perpendicular to C, yes. And C is perpendicular to D. So far, That looks like the right answer. Perfect. Okay. Oh my god, guys, I'm not gonna give you this many problems like this. This is annoying. Okay, it's once again, it's B. Alright, I think you guys get it, right? Oh god, what the heck is this? Okay. This will probably not be on your exam, because since A is perpendicular to B, that's true, and B is parallel to C by the perpendicular transverse theorem. What? Oh, okay, it can't be A because A is not parallel to C. Okay, A is, so let's look at B. Yes, the first sentence of B is correct. A and C are perpendicular. If A and C are perpendicular and C and D are perpendicular. Yeah, oh, okay, yeah, that does make sense, yeah. Okay. Street A is perpendicular to street B. Okay. So the map given, A is perpendicular to B. Okay, I think I might stop this here, and with the rest of these problems, I might screenshot them and then post them on my thing so I can actually start writing things. Okay, no, not right now. Eventually I will. So let's just take a look at this one. The map given to the right is a section. Street A is perpendicular to B, okay? B is perpendicular to C, okay? And C is perpendicular to D. Oh, okay, so it's just a square, okay? What conclusion can be made about street A and street D? Wait, they also have to be perpendicular. Yeah, guys, this question's easy because think about it. If A is perpendicular to B, so A is perpendicular to B, and B is perpendicular to C, right here, and C is perpendicular to D, then what shape is this? This is a square. So if this is 90, this is 90, this is 90, this one also has to be 90. So A and D are, street A is parallel, no, perpendicular. So it has to be B or C. So let's read on, because we can't just choose B, because what if it's C? Because it also says that street A is perpendicular to street D on both of these. So let's look at B. Street D and B are, no, street D and B are not perpendicular. Street D and B are parallel. So, yeah, so then it has to be this one by process of elimination. Okay. In a plane, QR, blah, blah, blah. Okay, it pretty much just is literally telling us. It literally shows it there. Okay. QR is parallel. RS is parallel. Okay, guys. So if QR is parallel and RS is parallel, then doesn't that mean that QR and S are all parallel to each other? Yes, we learned about that. That's transitive property. What will be my Q in this situation? My R. So if P to Q, then Q to R, then I can say that Q is also parallel to S. That's probably going to come in handy. PQ and AS. Okay. Prove that A is parallel to B. Okay. Okay. QR and RS is parallel. Okay, I know I was going to say QS. I knew it. QS, because of what? Two lines parallel to a third line theorem. We didn't hear it in that way, which is probably why this won't be on your exam. But that's why, because think about it. If Q and R is parallel and R and S is parallel, which was given to us, right? That was given. What do you think we can say next? That Q and S is also parallel. Okay. Now, if BQ is perpendicular, right? Because of this little box right there. Then I can say that yeah, Q and S, because of corresponding angles, no? Okay. Yeah, this one's a pain in the butt. Okay. B and S are definitely not parallel. Oh, it's B and S. Okay, so guys, the reason for this is that if B and Q are perpendicular, B and Q right here, then I know that B and S right here had to be perpendicular too. Had to be perpendicular as well. Alright guys, I'm going to skip this because I feel like I'm wasting my time because this is not going to be on the exam. This is too difficult and we haven't even two lines parallel to a third line theorem. Yeah, we have, and perpendicular transversal theorem. Yeah, we have, but I have a feeling it's not that. Okay, let's just finish it since we already started. If A and B are parallel, then what? Alright, that was a pain in the butt. Okay. Let me see, what is all this about? Okay, perfect. So I'm going to take the time to stop here on 30. I'm going to stop the video. I'm going to upload this one. And then I'm going to finish questions 30 through 47. Okay? Questions 30 through 47. All right, thank you guys. This is going to be part 1.